Good day. We're going to take a look today at performing operations with matrices. And we're going to begin with the first, most basic operations, which are addition and subtraction. So you can see I've already got 4 matrices set up here. It's important to note the size of the matrices. So when we state the size, we state the number of rows first, followed by the number of columns. So matrices A and B are considered to be 2 by 2 matrices because they each have 1, 2 rows and 1, 2 columns. So they're both 2 by 2 matrices. These lower ones here, C and D, are 2 by 3 matrices because, once again, there are 2 rows in total, but there are 1, 2, 3 columns in total. Okay, let's look at some examples. In our first example, we're going to be adding C and D. In order to perform the addition, you have to make sure that the matrices are exactly the same size. So this is the case for these 2 matrices, which again are 2 by 3 in size. So to perform the sum, all you do is add the corresponding elements. So -1 is added to 7. 4 is added to 9. -7 is added to -6. And that's how we determine the first row. And now we do the second row. 2 is added to 4. -6 added to -1. And 11 is added to -8. Just like that, we have the sum. When you're trying to subtract a matrix, it is easier to change the operation to addition. You'll note that in doing so, of course, we have to form a new matrix, -b. Okay, so let's try this. If we want to do A minus B, it's the same as doing A added to the negative of B. So A itself isn't changing, it stays exactly the same. The operation is now addition, but we're not adding B, we're adding its negative. So we have to form its negative first by changing the sign on all of its elements, like this. Now that that's done, we can add as we did in the first problem. So 6 added to -3, 4 added to 9, -3 added with -12, and -5 added with 6. And there is A minus B. Okay, now we're going to look at a scalar multiple of a matrix. So take a look at part C. We're going to do 2 times B minus A. Again, we're going to begin by changing subtraction of A to addition of -A. We're also going to form matrix 2B. Okay, so let's do that next. So let's form matrix 2B. This is formed by simply doubling all of the elements in B. So here's B, we double each element. Okay, so each element here is multiplied by 2. We now have the addition of -A is formed again by changing the sign on each element. Just like this. And now we perform the addition. Okay, so 6 added with -6, negative 18 added with negative 4, 24 added with 3, and negative 12 added with 5. Okay, we're going to do one last example before we turn our attention to multiplication of matrices. So in the original problem, we want negative 4c added with 3d. So what we'll do then is form matrix negative 4c, and we'll form the matrix 3 times d. Those are just going to be added together. Okay, so let's begin. Negative 4 times c. So we take every element here and multiply each of those elements by negative 4. So that will give us 4, negative 8, negative 16, positive 24, positive 28, and negative 44. That's the matrix negative 4c. We now have addition. We'll now form this matrix 3 times d. So we must triple all elements here. Like this. Now we add in this way. 4 plus 21, negative 16 plus 27, 28 added to negative 18. So that's how we form the first row of our answer here. And now we'll form the second row. Negative 8 is added with 12. 24 is added with negative 3. And lastly, negative 44 is added with negative 24. And we have our answer. Okay, so these first operations are pretty intuitive. Addition and subtraction of matrices. I've got a special note at the bottom reminding you these operations can be performed only on matrices of the exact same size. So you could not add A with C, nor could you add A with D, and so on. Okay, so we'll take a pause here. I'm going to put some suggested questions for you to try from 16.1 of your textbook, and there will be a second video that goes through multiplication of matrices.